So in this lesson, we are going to review solving quadratic equations by factoring, by using the quadratic formula, by completing the square, and then you get to choose your most convenient method for whichever equation you're given. But pay attention to each of your sections and make sure that you are actually solving them by how the directions ask you to. So for this particular section, we're going to solve by factoring. And I am going to start with number 5. So if you don't remember how to factor, you need to go back and review our factoring videos, but I'm going to use those methods here when factoring the quadratics. So you have to make sure that number 1, you have 0 on one side of the equation. So like here in number 8, we don't have 0 on one side. We have 12 on this side and these terms on this side. And in addition to that, you want your highest degree term, which is your x squared term, to be positive. So like on number 8, we will want to move the negative x squared to the right to make it positive. So you don't always move everything to the left. You move everything to the side where your x squared term is going to be positive. So that could be the right or it could be the left. But starting with number 5, it's set up in the form that we want it. We have 0 on one side, and then our quadratic is in descending order, highest degree to lowest degree on the left. The first thing you want to look for is a greatest common factor. Since 3, 13, and 12 do not all have something in common, we don't have a greatest common factor. So we are going to use the swing multiply method. So we're going to swing and divide. So we start by swinging and multiplying that 3 to the 12. And you end up with x squared minus 13x. 3 times 12 is 36 equals 0. So then you're going to factor this quadratic. It's always easier to factor when there's no coefficient in front of the squared term. But because we multiply by this 3, we're going to have to eventually down here divide that 3 back out again. So off to the side, I'm going to find the factors of 36 that add, because 36 is positive, to give me 13. If this were negative, we would subtract the factors of 36. So whatever the sign is of your constant tells you whether you're going to add or subtract those factors of this constant to get this middle term. And again, review those factoring videos if that didn't make any sense. So we're going to find the factors of 36 that add to give us 13. So 1 and 36 gives you 37. 2 and 18 is 20. 3 and 12 is 15. 4 is next. 4 goes into 36 9 times, and there it is. So 4 and 9 add to give us 13. Our 13 is negative, so the bigger of the two carries that same sign, and the 4 is also going to have to be negative. So in my parentheses, x squared becomes x and x, and then we are going to put the minus 4 and minus 9 right here. So minus 4 and minus 9. But you're not done, because we now have to take that 3 and divide it only to the number part. And if this 3 does not divide evenly to this 4, as it doesn't, it's going to pop in front of that x. So we get 3x minus 4 times, and then this 3 divides into that 9, so we get x minus 3 equals 0. So this truly is the factoring of this quadratic up here. If you go ahead and refoil or double distribute, right, and collect like terms, you will get this right here. But don't forget to do that division. So now, if this times this is equal to 0, if you have a product that equals 0, one or both of these must have a value of 0 for that product to be 0. So we have to take each of these and set them equal to 0. So we should have 2 different solutions for x. So on this one, I'm going to add 4 to both sides and divide by 3. And on this one, I'm just going to add 3. And so my solutions are x equals 4/3 and x equals 3. Do not give me a decimal answer. All right, so I want you to try number 6, but before we do number 6, we are going to put it in the proper order, and we're going to ask that most important question first. So, number 1, I want everything on one side where x squared is positive. So that means the 12 is going to move over to the left, and we're going to subtract it. So we get 6x squared plus 21x minus 12 is equal to 0. Then even though you could swing multiply, you are going to miss your greatest common factor when you do that, and you can oftentimes mess up your answer. You have to look at your numbers, make sure that there isn't a greatest common factor, which in this case there is. 6, 21, and 12 all have a 3 in common. So we are going to divide both sides by 3, which means I divide every term by 3. And since my GCF does not have a variable in it, I can divide the 0 by the 3 as well. So in this particular case, I won't pull the greatest common factor out in front because I'm going to divide it out. If we had an x in common, we would not be able to divide by that x because you would lose one of your solutions. But in this case, since I don't have a variable, it won't matter. So I end up with 2x squared plus 7x minus 4 is equal to 0. And now I want you to pause the video, and I want you to do that swing multiplying, and I want you to factor this quadratic, set each factor equal to 0 and solve, and then you can restart the video and see if you're correct. So you would get x squared plus 7 plus 7x minus 8 equals 0. So we're going to factor this. So we're going to find the factors of 8 that subtract to give you 7. So the factors of 8 that subtract to give us 7. So 1 and 8 subtract to give us 7, and there it is, first shot. So our 7 is positive, so 8 carries the sign of that term because it's the largest. The 1 in this case is going to have to be negative to combine with that 8 to make a 7. So x squared is x and x, and then we're going to have a minus 1 and a plus 8 straight from that chart. But don't forget to go back and divide out 2 into each of those numbers. And in this case, 2 doesn't divide, so it pops in front. Here, 2 does divide. So we get 2x minus 1 times x plus 4 equals 0. 2x minus 1 equals 0. And x plus 4 equals 0. And then 2x is equal to 1. And x is equal to 1/2. And x is equal to negative 4. So those are your two solutions. Hopefully you did that correctly. All right, then I've got 2 others in this section I want to do, only because I have something to point out in each of those. So the other problem that I'm going to do in this section is number 8, and we kind of talked about it earlier. But for number 8, we don't have 0 on one side, and your x squared is not positive. So we want to move the negative x squared and the 8x over to the right and write it in descending order. So we're going to have a 0 on the left because we're moving everything on that left side. So I'm going to add an x squared, so I get a positive x squared. I'm going to subtract an 8x from both sides, so I get a negative 8x, and then I already have a positive 12. So this is your trinomial you're going to factor. There is no greatest common factor, and there's no coefficient in front, so there's no need to swing and multiply and then go back and divide. So this one should be pretty easy. Go ahead and factor this trinomial, set the factors equal to 0, and get your 2 solutions. So pause the video. Okay, so if you read this backwards, you are finding the factors of 12 that add to give you 8. So the factors of 12 that add to give us 8, and our 8 in this case is negative. So 1 and 12 give you 13. 2 and 6, there it is, give you 8. So our 8 is negative, so the bigger of the two carries that same sign. The 2 is also going to have to be negative. X squared becomes x and x, and then you have minus 2 and minus 6. So x minus 2 is equal to 0, and x minus 6 is equal to 0. X is equal to 2, and x is equal to 6. There are your two solutions. All right, and then the last one in this section that we're going to do is number 12. Because number 12 has an interesting answer. So again, like 8 and 6, we don't have 0 on one side. I'm losing my voice. But your x squared term here is positive, so I want to move the 10x over to the left side, and it's going to move here in the middle between these two. I'm going to subtract the 10x from both sides in order to move it. So you end up with x squared minus a 10x plus 25 is equal to 0. And so at this point, I want you to pause the video. I want you to find the factors of 25 that add to give you 10. There's no greatest common factor, no swing and divide necessary. And then I want you to determine what's interesting about this answer. All right, so we are going to find the factors of 25 that add to give us 10. So 1 and 25 add to give us 26. 2 doesn't go in there, 3 doesn't go in there, 4 doesn't go in there, but 5 does. So 5 times 5, and those add to give us 10. We want our 10 to be negative, so the bigger of the two carries the sign. Well, they're both the same, so they both carry that negative. And so your two binomials, x squared is x and x, and then minus 5 and minus 5. Well, both binomials are the same, so you really only have to set one of them equal to 0 because they're both going to have the same solution. So that means that you only have one solution, x is equal to 5. So that means that this is called a double root. Double root meaning you have two roots, two zeros that have the same solution. So this means that your parabola, because these all graph as a parabola, is sitting on the x-axis, the vertex, at 5. So I know the vertex is sitting here on the x-axis at 5 anytime you have a double root. And because our highest degree term, x squared, is positive, I know that this parabola is going to open up. So that's what my parabola is going to look like. Now, if we go back to, let's say, let's see if I can move this. Whoops, here we go. Let's go back to number 8. I want to focus on what these solutions mean really quickly before we go to the other ones. And as a reminder, your zeros or your roots, your solutions, are where this parabola is crossing the x-axis. So in this particular case, we have a 0 at 2 and 1 at 6. So what that means is our parabola is going to cross the x-axis at 2 and at 6. And because in our original problem, our x squared was negative, you could say that it opens down. You could also view this one and say that our parabola opens up. It really doesn't matter which way you choose to do that, because neither here nor there your parabola is going to cross through those 2 points. I don't know where my vertex is at the moment, but that doesn't matter because our focus solely is on these roots. So don't forget that your solution is where the graph is crossing the x-axis. Okay, so let's move on to the next section, which is using the quadratic formula. So before we get into these, let's talk about that quadratic formula. So you're going to be using a general form of a quadratic, standard form, which is ax squared plus bx plus c equals 0, because we're going to let our y value be 0, because that's where we're focused, is where the graph crosses the x-axis. So the formula that you need to use and need to know is this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So all of these problems, I'm using this formula to substitute in. If you don't know this formula, you need to write it down each and every time you do a problem in this section, because the more times you write it down, the more likely you are to actually learn it. So let's look at number 14 and 17. So we're going to do 14 and 17 only because 17 has an interesting answer as well. So the first thing you need to do, and I want to see this, is you need to list out your A, B, and C. So in this case, my A is the coefficient of the x squared term, which would be 2. My B is the coefficient of the x term, which in this case would be -1. And my C is always my constant. So if you're missing one of those terms, you need to know that it's not just in that order. You have to know that A is your coefficient of the squared term. You shouldn't ever be missing that one. And then you might be missing one of these two. So you have to know that B belongs to the coefficient. It's the coefficient of the x term. So that if you're missing this one, you know that this is not B, it's C, because C is always the constant. C for constant. All right, so I'm going to substitute into that formula. So X is, and I always use substitution parentheses. If you don't use parentheses, you are going to suffer from sign errors. So I like to call this my template or a blueprint. So you are creating that blueprint or that template first, and then you're going to substitute in here after the fact so that you don't make sign errors. So this is going to be B here and here, A, C, and A. So here we go. The opposite of B, so -1 goes here and here, and then for A is 2, C is -10, and then 2A, so there's a 2. And then you're going to simplify. So a -1 is 1 plus or minus the square root of, and then -1 squared is +1. Negative and a negative is going to make a positive. 4 times 2 times 10 is going to be 80. So we end up with 81 underneath the radical. All divided by 2 times 2 is 4. So then this equals 1 plus or minus the square root of 81 is 9. All divided by 4. You have to perform that math. So that means X is equal to 1 plus 9 divided by 4, and X is equal to 1 minus 9 divided by 4. So we get 10 over 4 and 8 over 4. Please reduce. So 2 goes into both 10 and 4, so you get 5 over 2. And 4 goes in there evenly, so you get a 2. So your two solutions to this quadratic by using a quadratic formula are 5/2, and oops, I should have had a negative here. So that makes this a -2. So -8 over 4 is -2. What that tells you, since these are nice rational answers, that you could have factored this. I will always factor if I can, but you can use a quadratic formula to solve any quadratic no matter what. So this is always one that you can use. So if you're uncomfortable with factoring, you can always use this. All right, let's go ahead and look at number 17. So number 17 has a couple of issues. Issue number 1, you have to have 0 on one side. So same thing as the previous section. If I can make my x squared positive, I tend to, if I will, if I'm already moving terms. So I'm going to move this one in the middle by subtracting it. So we end up with x squared minus 10x plus 4 equals 0. So list out your A, B, and C. So A is 1 because that's the coefficient of the squared term. B is -10, and C is +4. So prepare your template. X is the opposite of B, plus or minus B squared minus 4 times A times C all over 2A. All right, so let's substitute in our numbers. So we have negative 10 here and here. And then we have a 1 here and a 4 here, and then a 1 here. So x is the negative 10 is a positive 10 plus or minus the square root of. Here, negative 10 squared is 100. 4 times 1 times 4 is 16. So 100 minus 16 is going to give us what, 84? So we get 84, all divided by 2. So now 84 needs to be factored out. So I like to try to find perfect squares within my my number underneath this radical. So I know that 84 is divisible by 4. 4 is a perfect square. So 4 goes into 84 21 times. The only numbers that divide into 21 are 3 and 7, so I cannot make another perfect square. So I'm going to take the square root of the 4 and bring it out in front and leave the 21 underneath. So I end up with x equaling 10 plus or minus the square root of 4 is 2, so that's where the 2 is coming from, times the square root of, and then 21 stays underneath, all divided by 2. So you're not done. You have to look at, I like to call this my Superman triangle of numbers. So you have to look at all 3 of these. If the 2 weren't here and you just had the 10 and the 2, you cannot reduce 10 and 2. You have to reduce all 3 of these because this term and this term are both divided by 2. You can't divide one without dividing the other. So if you look at this triangle of numbers, what do they all have in common? A 2. So 2 divides in here once, 2 divides in here once, and 2 divides in here 5 times. So your actual final answer is x equals 5 plus or minus, we now have a 1 in front, so you don't have to write it, square root of 21, and it's all over 1, which we don't write, over 1. So this ends up being our final answer. You can separate these out if you want to, 5 plus the square root of 21 or 5 minus the square root of 21. It's your choice. All right, so we just have one more in this section to do, which is on the back page, number 20. All right, so let's look at number 20 on the back. I think it's a smidge crooked. There we go. All right, so I want you to pause the video and I want you to use the quadratic formula. This one's going to have an interesting number underneath the radical. Let's see if you can remember what to do with that. If not, you can wait until I finish the solution, but go ahead and start it anyway. Find your A, B, and C and run it through the formula. Pause the video. Okay, so our A is 1 because that's the coefficient in front of the squared term. Our B is negative 2. That's an equals. And then our C is 10. So then if I run it through our formula, x is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So our B is negative 2. It's just a coincidence that all of our B's have been negative on these examples. Don't let that affect you. And then our A is 1, and our C is 10, and our A is 1. So you should have had positive 2 plus or minus the square root of negative 2 squared is 4 minus 4 times 1 times 10 is 40, so that actually gives you a negative 36 underneath that radical. Well, normally we cannot take the square root of a negative, so this is going to give us an imaginary answer. So if you recall, this is really 2 plus or minus the square root of negative 1 times 36 all over 2. So I have 2 plus or minus. The square root of negative 1 is I, right? and the square root of 36 is 6. So I end up with a 6i all over 2. Now, don't forget your Superman triangle of numbers. All three of those, 2, 6, and 2, are divisible by 2. So 2 goes in there once, 2 goes in there 3 times, and 2 goes in there once. So you end up with 1 plus or minus 3i all over 1. So you can split that into 2 different answers or just leave that as one answer. Okay, so let's go to our next section, which is solve by completing the square. So in this particular section, you really want to get one side as a squared binomial and everything else on the other side, so your constant should be on the other side. You are going to create, and this squared binomial is the factored pattern for a perfect square trinomial. So you need to make sure that you've created a perfect square trinomial on the left, and then your constants and everything else is on the right. So how do we do that? Well, let's just start here. We're going to start backwards a little bit. So I'm going to do number 23 with you. And if you get to the point, because this is our whole goal, if I have a squared binomial here, I'm going to isolate it on one side and put whatever my constant is, positive, negative, 0, over here on the other. So once this is isolated, nothing in front, nothing underneath, then you can take the square root of this left side. When you take the square root of the right side, don't forget that you have to do plus or minus the square root, because this value, x minus 3, could come out to be positive. It could come out to be negative, because when squared, it should give you a positive 18. So, because our index here is 2, remember that I can divide anything written as a power, I can divide that exponent by the index to get the root. So, the square root of x minus 3 squared is x minus 3 is equal to plus or minus the square root of, and I'm going to write out the prime factoring of 18 as 2 times 3 times 3. So I want to simplify this radical, so I'm going to take a pair of 3's out in front, and only one 3 will come out in front, so we end up with x minus 3 is equal to plus or minus, then the square root of that 3 times 3 comes out to be just 3, and then that 2 gets left underneath. So all I have left to do to solve for x is to add 3 to both sides. You want to make sure that you add that 3 in front of the plus or minus. So we have x is equal to 3 plus or minus 3 square root of 2. And that is your solution. You can split those two out if you want to, or leave them as is. I prefer to leave them as is. So our goal is trying to get our quadratic into this form. Well, how do we get there? So let's look at number 26. The first thing you want to do is, now I promise you we are not going to give you trinomials to factor that have a coefficient in front of the squared term, because quite honestly, if I were given the choice and I have a coefficient in front of the squared term, I'm not going to complete the square, no matter what. I'm either going to factor or use a quadratic formula. I would never choose to complete the square if I have a coefficient in front. So we're not going to do that to you. And then I also would never choose to complete the square if this middle term, your b, is not divisible by 2. So all of these on this particular page, the b's are divisible by 2, so that's nice. However, your constants might not come out to be a perfect square trinomial. So even though 1 is a perfect square, if I took the square root of x squared and the square root of 1 and multiplied them together, I would have x times 1. And then if you double it, that's how you test it to see if you have a perfect square trinomial, I would get 2x. Well, that's not what I have here. So I cannot factor this as a square binomial. In fact, there are no factors of 1 that add to give you 10. So we are going to get rid of that constant and create our own constant that will make a perfect square trinomial. So I'm going to move the 1 to the other side by subtracting it. And so I'm going to add in some blanks. So I've got x squared plus 10x plus blank equals a -1 plus blank. The reason for the blanks are we're going to create our own constant to make this into a perfect square trinomial so that it will factor as a squared binomial, and whatever I add to this side, I must add to this side to maintain my equality. To find this nice constant, you need to remember to find our constant, you're going to take whatever your b is, you're going to divide it by 2, and then you'll square it, and that will create the perfect constant to make this into a perfect square trinomial. So here we go. So our b in this case is 10. So I'm going to put my 10 in here. 10 divided by 2 is 5. Squared is 25. So if I put a 25 on that line, I need to also put it on that blank as well. If you read this backwards, the factors of 25 that add to give us 10 would be 5 and 5, which means that both of our binomials would be the same. So this should factor into one binomial squared. Now, each of these contributes something to the factoring here. You're going to take the square root of your bookends and put them here. So I call these your bookends because it's your first and your last. So the square root of x squared is x, and the square root of 25 is 5. And then the sign of your middle term, this plus, is what your sign is here. So if our middle term was negative, it would have been a minus. And then -1 plus 25, we get 24 on the right-hand side. And so now we're going to do what we did on question number 23, and we are going to take the square root of both sides. Don't forget to do plus or minus over here. So I get x plus 5 on the left equals plus or minus, and I'm going to prime factor 24, which is 2 times 2 times 2 times 3. So I can only make one group of 2 to pull out in front. So I get x plus 5 is equal to plus or minus 1, 2 gets brought out in front, and 2 times 3 is 6 is going to stay underneath. So I get a 6 underneath here. Solve by subtracting 5 from both sides. Remember that 5 must go in front of the plus or minus. So we get x is equal to -5 plus or minus 2 square root of 6. Now, if you get down to this point and you can actually perform the math, in other words, you could take this -5 and add or subtract this number to it and get values, you must. But here, we can't. So we're going to stop there. You're done. If you need more work on this, come talk to me and I can run you through some more problems. But that's your review of completing your square. Then the last part is this section here, and I'm going to zoom back out a smidge. Now, I'm not going to do any of these with you, but you can use whichever method you want to. So if I can factor, I'm going to factor. So like on this one, even though it's a swing multiply, it's quicker than using the quadratic formula. I definitely wouldn't want to use on this one, completing the square. Number one, we have a 6 here and I can't divide it out. And number 2, this is not divisible by 2. So anytime I have a coefficient, the completing the square is out. Are there factors of 6 times 3, which is 18, that subtract to give you 7? Yes, there are. So I personally would factor on this one, but you could also definitely use a quadratic formula. Either one's fine. This one is perfect for completing the square. There's no coefficient in front of the squared term. And this is divisible by 2. So if you're really comfortable with completing the square, this is actually quicker than factoring, because there are no factors of 4 that add to give you 8. So this one's not going to even factor. So you're left with either completing the square or the quadratic formula. And then don't forget that when you have a problem like this, you have to move everything over to one side and let one side be 0 before you can determine which is your most convenient method. And so on this one, you're going to subtract 5. Again, there's no coefficient here, but I'm not going to use completing the square because this term is not divisible by 2. So I would either use a quadratic formula or factor. So good luck. Finish the problems you've been assigned, and then ask us for help when you need to.